Let's do it this way. Might as well. Okay?
I'm all for it.
All right. Welcome back. Over the last 4 episodes, we've looked at that very old mammalian midbrain biology that explains 2 core phenomena of addiction. We looked at how the feedback loop between the ventral tegmental area and the nucleus accumbens sets up the spike and crash that causes compulsive use. And we talked about how it's low dopamine tone at the nucleus accumbens that sets up the symptoms that get people to seek reward in the first place. Together, these 2 explain almost everything we see in the core of addiction. But there's still one thing more. People with addiction have long talked about a sudden, out-of-the-blue craving. Somebody's walking along, feeling fine, no thought of using, and they don't just fall off the wagon, they dive off the wagon. They talk of a euphoric recall that comes on suddenly and leads to an irresistible craving. These stories are so inexplicable that they just fill us with fear and confusion. We don't know what else to do, so we turn to locking people up and prohibiting substances. Well, if we're going to have a more rational response, we're going to need to understand the biology of this phenomena. And for that, let's go back to our diagram from last time. Here's the ventral tegmental area, and here's the nucleus accumbens. Off to the side is another group of cells called the amygdala. The amygdala is the storage site for emotional memory. It doesn't remember who did what to whom when. It remembers how you felt about who doing what to whom then. When the amygdala is stimulated by a memory, a sight, a sound, a smell, it sends a signal using another chemical called glutamate to the ventral tegmental area. The glutamate causes the sudden release of dopamine, which in turn causes the sudden release of endorphin from the nucleus accumbens, and this goes around and around, causing a spike and a crash. It's as if you took a drug, even though you didn't. So it's not euphoric recall. It's real euphoria. And it's not the memory of a crash. It's a real crash. And if it goes low enough, your midbrain's going to be screaming, you're going to die unless you fix this dopamine tone, and fast. That's the nature of the midbrain reward system. That's what it's there for. But why don't people with addiction talk about the cue that they noticed? Well, they didn't notice it. This is all happening at the level of the midbrain. That's far below the part of your brain that you're conscious of. When scientists studied this phenomena, they noticed that cues so fast they couldn't even be registered in the conscious mind still lit the amygdala up and still caused craving. So imagine feeling fine. No symptoms of low dopamine tone, no thoughts of using. A guy in your peripheral vision uses a red Bic lighter to light his cigarette, and your amygdala sees the lighter and says, I remember crack! Suddenly, glutamate's pouring out of your amygdala to your ventral tegmental area. Your ventral tegmental area is sending dopamine to your nucleus accumbens, which is sending endorphin back, creating even more dopamine. You're spiking. You're getting the euphoria of a hit of crack even though you didn't take any, and now you're crashing. You're in a low dopamine state. You need to survive. Your brain is screaming. You've got to find a source of dopamine. What are you going to do? Well, that guy's got cigarettes. That'll work. We started this series talking about our response to addiction in this country and how we weren't getting what we wanted because our responses were causing negative consequences. Those responses were based on 2 assumptions that are quite erroneous. 1, that drugs cause addiction, and 2, that addiction lies in the cortex, thinking, deciding part of the brain. In the second part, we showed you what addiction really is in nature. Not the disease we want it to be, but the midbrain, old, mammalian brain disease that it really is. We started with Shakespeare, talking about human attachment and how that was not a choice. When he coined the term addiction, he had something else in mind. And we showed you that biology, that midbrain spike that causes attachment in mammals. The crash that results from that spike explained Dr. Silkworth's compulsive use phenomena that he saw in his patients with addiction. And the low dopamine tone at the nucleus accumbens explained the other phenomenon, those primary symptoms that cause people to seek reward in the first place. And today we talked about the biology of cue-induced craving. So, do we still want to believe that addiction is a cortical choice and a syndrome caused by drugs? Or would we do better by understanding addiction as a primary, chronic, progressive, terminal but treatable illness of the brain? We're going to take a look at what that really means next time. I hope you join me. Until then, be well.